All right, we're in section 1.3 where we're going to use midpoint and distance formulas. So we should all be pretty familiar with midpoint. By definition, midpoint is the point that divides a segment into two congruent segments. But one of the terms that you may not be as familiar with is segment bisector. Segment bisector is a point, a ray, a line or a plane that intersects the segment at the midpoint. All right, maybe you've been more familiar with perpendicular bisector, which means that a line or a ray or a point or whatever may intersect, but it also will intersect at a 90-degree angle. That doesn't necessarily mean that in, let's say if we added a line right here and it was like QZ, QZ bisected line segment XY, but it didn't cross it at a perfect 90-degree angle. We just know that it bisected. Anytime we know that it bisected, by definition, that means that XZ and ZY would be congruent, which means that point Z is the midpoint. And then here we have, the hash marks representing that XZ is equal to ZY, which also means is that even when they're equal, they're also congruent. So we can say that XZ is congruent to ZY. So looking at some example, we have, they want us to find the value of RS. So RS is this entire line segment. So what they told us is this: we have line segment RT, which is 21.7, and we have a line segment TS, which doesn't have a measurement at TS, but we have these hash marks saying that they are equal. So we can say at this point, because point T is a midpoint of RS, we can say that RT and TS are going to be equal, and they're both going to equal 21.7 units. So from here, we can say, all right, RS is equal to RT plus TS from the segment addition postulate. Well, we have values attached to those line segments. They both just so happen to be 21.7. Once you add those together, we can say that it is 43.4, and we know that RS is 43.4 units in length. From here, they told us that point C is the midpoint of line segment BD. They want us to find the length of BD. Excuse me. So in order for us to find the length of BD, we first need to find the value of X, because yes, they gave us measurements, but they attached a variable to it. So we're going to have to do some algebra. Well, because it's a midpoint at point C, we know that BC and CD are going to be equal to each other. Since they're equal to each other, we can substitute those values in for BC and CD respectively to solve for X. So BC is 3X minus 2, write that in. That's going to be equal to 2X plus 3. So doing some algebra, I can subtract 2X from both sides. I can add 2's to both sides. So cross this out, I get 3x minus 2x, which is just x, and 3 plus 2 is 5. So we have x equals 5, but that didn't tell us anything because they want us to figure out what the length of BC is. So what we must do now is evaluate BC when x is now 5. So then we go over to BC and say, all right, well, BC is 3x minus 2. Now we know that x is 5. We can substitute that in. So now I can say that this is 3 times 5 minus 2. 3 times 5 minus 2 is what? 15 minus 2, so this is going to be 13. So we know that BC equals 13 units. There's a way to check this one because we have two values that we know that are equal. We can substitute in 2 times 5 over here and add it to 3 because that's CD. If this is also 13, it kind of validates our solution for the previous problem. So now I got 10 plus 3. 10 plus 3 is in fact 13. So that proves that 5 was the correct value for X. All right, looking over here, it's saying that point K is the midpoint of JL. They want you to find the length of KL. So KL is right here. Same idea, because all they gave us is values with a variable attached to it. We have to find the value for X. So we can set these equal. So we can say that JK is equal to KL, just like the one up top. And that's 8 minus 3x is equal to 2x plus 5. So I go over here and I'm like, all right, so I add 3x. I'm going to subtract 5. So now I got this gets canceled and this gets canceled. So now I'm left with 3 equals, looks like what, 5x. And finally, what, divide 5 to both sides. So x equals 3 over 5. If you want to write it as a decimal, it would be what, 0.6. And since they want us to find KL, we need to substitute this into the problem. So now I got 2 times 3 over 5 plus 5. So now I have 6 over 5 plus 5, and 6 over 5 plus 5 is would be, if you wrote it as a decimal, it'd be like 6.2, or you could write it as an improper fraction. You could write it as 31 over 5, or you could write it as a mixed number, which would then be 6 and 1/5. When you're looking at coordinates, we have a midpoint formula. So anytime that you have 2 points like A and B here respectively, you are given a coordinate. In this case, to generalize, we say x1 and y1 for A and x2 and y2 for B. In order to find the midpoint M for line segment AB, you're going to use this formula. You're going to essentially get a coordinate, and it is the sum of the two x values divided by 2, and it is the sum of the two y values divided by 2. So remember, when you're dealing with the midpoint formula, your answer is going to be a coordinate. So like an x comma y. All right, so from here, they want us to find the midpoint of line segment PR. So in order to find that, again, it's a coordinate. So first off, you're going to find the x coordinate of your midpoint. You're simply going to take the two x values, add them together. -2 plus 4, and then divide it by 2, comma. You're going to take the two y values, add them together, divide it by 2. So -2 plus 4 is 2. 2 divided by 2 is 1. So that's my x coordinate. 5 plus 3 is 8. 8 divided by 2 is 4. So my coordinate midpoint is 1 comma 4. So here it says we got endpoints CD. C is -8, -1. D is 2, 4. They want us to find the coordinate of the midpoint M. So again, it's a coordinate. We take the two x values, -8 plus 2, divide that by 2, comma, add up the two y values, -1 plus 4, and then we divide that by 2. Negative 8 plus 2 is negative 6. Divide that by 2, I get negative 3. Negative 1 plus 4 is 3. Divide that by 2 is 1.5, or 3 halves. Now, this one here is a little bit tricky. Most people have a hard time solving these because in this particular one, they give you the midpoint. They're telling you that the midpoint is 3 comma 4. The other information they give us is one endpoint is 6, 1. So what they're asking for is they want us to find the other endpoint. So in order for us to find the other endpoint, you're going to utilize the midpoint formula, but just in a different way. So here, to find the x endpoint, so to find the x endpoint in this case for point C, because you got A, we need to find C. What you're going to do is you're going to use the x coordinate from the midpoint, which is 3. So I'm going to put 3. That's going to be equal to. Now what you're going to do is you're going to use this portion of the formula, and you're just going to say x2 is the portion for C. So you can just use it as the variable. So x1 is from A, so I can say that 1 plus x, which is x2. You don't need to write it in, and then it's all divided by 2. In order to find x in this one, you're first going to multiply both sides by 2, because that'll cross out here on the right hand side. And now I have 2 times 3, which is 6. 6 is going to be equal 1 plus x. Subtract that by 1. I get 5 equals x. All right, so that's my x coordinate for point C. Now we need to find our y endpoint for point C. And you're going to do the same thing. Now we're just going to use the y portion of this. So we're going to take our y midpoint, which is 4. So now I got 4 equals. Now I go over to my y coordinate for A, which is 6. Now I got 6 plus y, all divided by 2. Multiply 2 to both sides. I got 8 equals 6 plus y, because these cancel. Subtract 6 from both sides, and I have 2 equals y. So my endpoint for point C is 5 comma 2. And then you can double check that. So like say I want to find, the midpoint of AC, and okay, I got 1 for x right here, and I got 5 for x over here. 1 plus 5 is 6. Divide that by 2 is 3. All right, that checks out. I go over and I see 6 for A for my y coordinate plus 2 for my y coordinate for C gives me 8. Divide that by 2, I get 4. It checks out. So that's another way you can check it. So here's the endpoint, 5, 2. Same idea. You are you have a midpoint of xz where the midpoint is 5, negative 6. One endpoint x is negative 3, 7. They're asking you to find the coordinates for point z. Okay, so same idea. So let's find the x coordinate for z. I go over here and okay, all right, midpoint is 5, so midpoint's going to be 5. That's going to be equal to now x coordinate for x is negative 3 plus x all divided by 2. Multiply 2 to both sides. I get 10 is equal to negative 3 plus x. Add 3 to both sides. I get 13 for x. Now we go for our y coordinate for point z. Same idea. I got negative 6 as the midpoint, so that's where it's going to be equal to. And the y coordinate for x is 7 plus y all divided by 2. Multiply 2 to both sides. I got negative 12 equals 7 plus y. Subtract 7 from both sides. I got negative 12 minus 7. That gives me a negative 19 for y. So now my coordinates for point Z are 13, comma, negative 19. Again, you can check. So if I go 13 plus negative 3, that's 10. 10 divided by 2 is 5. Checks out. I go 7 plus negative 19. That's negative 12. Divided by 2 is negative 6. Checks out. So again, there's ways you can check to see if you have the correct endpoint. Now, midpoint formula was a coordinate. The distance formula now is just going to be a number. Okay, so it's a distance. It's not a coordinate, it's a distance. So you're going to get just a singular value for whatever the distance is between two line segments. So here they're telling us that A and B are on a coordinate plane. A is x1, y1, B is x2, y2. Those are just, those can be flipped if they needed to be. And AB, the distance, to find the distance is just going to equal the square root of the the um, the difference of the squares of the x values plus the difference of the squares in the y values, and you add up those sums. So if we look at this first example, they want us to approximate the length of RT. So they say approximate, which means that there's the possibility that we may have some decimals and it's not an exact answer. So they're giving us the freedom to approximate if necessary. We have one endpoint that is negative 4, 3, which is T, and we have one endpoint that is R, which is 3, 2. So again, it does not matter which values you denote as your x1, y1, or your x2, y2. All you have to know is you just have to be consistent with uh, with the formula. So I'm just going to go up here and say, all right, this is my x1, this is my y1, x2, y2. And I just simply plug it into the formula. So I can say that RT is going to equal the square root of, and it's going to be the difference of, so it's what, x2, so it's going to be negative 4 minus 3 squared plus, and I'm going to have y2, which is 3, so it's going to be 3 minus 2 squared. Take care of all the stuff inside parentheses. So I got negative 4 minus 3, which is negative 7. Square that, I get 49. So now I got the square root of 49 plus 3 minus 2, which is 1. 1 squared, which is 1. So I got square root of 50. And if I took the square root of 50 and approximate, which is they're allowing us, it is about 7.07 units. I usually go to the nearest hundredth when I approximate, unless they specify something else. All right, so finally here, same idea. They want to approximate the length of GH, where they give us two endpoints. Again, denote the values of x1, y1, x2, y2. I could have had those flipped. I could add x2, y2 for 5, negative 1. Negative 3, 6 was my x1, y1. It wouldn't have mattered. It's still going to be the same answer, just as long as you're consistent with the formula. So GH is going to equal, I go over here, I got negative 3 minus 5, square that, plus 6 minus a negative 1, square that. So looking at the first set of parentheses, I got negative 3 minus 5, which is negative 8. Squaring that, I get 64. So 64 plus 6 minus a negative 1, that gives me 7. 7 squared, which is 49. Take 64 plus 49, I get the square root of 113. All right, that again, that's another approximation. Square root of 113 is about 10.63 units. And that is being able to use midpoint and distance formula. Hope this helps. Until next time.